right, guys, welcome back. Back here at the back of the truck again, and it's starting to feel like fall or winter. It's jumped from really hot to really cold. As you can tell, the leaves are falling, but it actually feels pretty good outside. Want to bring up a revisited topic that I've had as far as an ongoing issue on Ruby, the Red Coupe. And the main issue is the fuel system, not necessarily the plumbing or anything like that, but more so cavitation at the pump. It's an issue that I've never really run into in the past, just because I've never really had for myself a setup that demands the fuel system that it needs on the street. And what do I mean by that? Well, as you guys know, she has a Dart 4-bolt block. It's a 363 cubic inch AFR 195 heads. Built pretty well. B41 HR Anderson Ford Motorsport cam, and a Paxton Novi 2000 supercharger. And I have 71 pound injectors, high impedance on it. And so to feed that kind of horsepower at wide open throttle, you need a pretty good sized pump. Really and truly, somewhere around the 400 to 450 liter per hour would be absolute minimum. Or not minimum, but let's just say that would be the absolute bare minimum on safety, I would say. So I upgraded to, and you can see in my earlier videos, I have a Holley 525 liter per hour pump, which is the Hellcat pump, the TI Automotive 285 pump, which is the last three digits in the part number from TI Automotive. They use them in the OEM market, so it's a pretty good pump. What I've been noticing is after I drive for about 30 minutes, in warm weather, if you stab the throttle, pressure will drop, and it's not because the pump can't keep up. It's simply because the pump, if you don't use some sort of controller on the pump, it moves so much fuel and cycles so much fuel through the lines that it actually picks up heat when it goes through the engine bay and then returns back to the tank. And over time, the temperature of the fuel rises in the tank. And what happens is, being that fuel has a pretty low boiling point at the inlet of the pump, if the temperature of the fuel has gotten to the point where it cavitates and vapor locks, the fuel can no longer enter as a liquid into the inlet of the pump to move it through the lines. So I was noticing this issue a few months back, not too soon after I put the Holley 525 in, which again, great pump, love it, highly recommend it. So through some research and whatnot, I determined that I needed a fuel pump controller. And we're going to go into how these fuel pump controllers work a little later on. But just a general overview, what they do is they control the duty cycle to the pump. And what is duty cycle? Just like an idle air bypass valve on the side of our throttle body, instead of a solid 12-volt stream of current going to the solenoid, pump, whatever the electrical load is, there's a cycling on and off very rapidly to control, in this case, the pump speed. Voltage stays the same, but the on-off speed, or the duty cycle, is what changes, and that's what determines the speed of the motor inside the pump. The goal there is, when you have such a massive pump but you're not drawing a lot of fuel, the engine is not consuming a lot of fuel, if you slow the pump down, you reduce the volume of fuel going through the lines, which in turn reduces the heating up of the fuel. But you also want the fuel there when you demand it under high load conditions. So that pump has to be sped back up to be able to move the volume that the engine is demanding whenever it's demanded. So a fuel pump controller is pretty much the only option. Well, through doing some more digging on the net, I discovered a company called VaporWorks. Basically contacted them via email. They have several different fuel pump controllers available depending on what your application is, and received a call back about 30 minutes later from VaporWorks, and the gentleman on the other end of the line had about an hour conversation with me, going through what, the setup I had, and I told him exactly what I had, what my goals were, and he recommended me a fuel pump controller that he has on his site. So I went ahead and made the purchase, and let's just say I'm going to show you how to install it, what my thoughts are on it, and we'll go from there. All right, guys, so this is the VaporWorks standalone fuel management control unit. This is what comes in the kit. What I've opted to do is use this kit in lieu of the Aeromotive unit, as stated before. The cool thing about these units is they're still pulse width modulated, as well as coming with a standalone map sensor. They have an option where you can use the factory map sensor for you guys out there that want to use your stock one. But I'm going to use the aftermarket one, or I say the aftermarket one, the standalone unit that comes as an option for this kit. I wish I would have started filming from the very, very beginning. I got a little antsy. I have mounted the map sensor and block that comes in this kit, and I'm going to show it to you right now. So here's the map sensor and the block. It's a little dark, but if you can see, it says VaporWorks right there, but that's the block, and it comes with an AC Delco map sensor, and it comes with a brass fitting barb on the back side, which is hard to see, and also probably about 4 feet of vacuum line, and that's how it's mounted. So what he gives you is obviously the control unit, the map sensor and block that you just saw, the connector that you're going to use for the map sensor, because you're going to have to actually cut the wires to length, crimp the bullets, and make the connector. So he gives you that, and also all the wiring. Now let's see what's in here. Looks like we have a 40 amp fuse, some ringlets, some heat shrink, and quite a bit of wire loom. Sorry guys for the camera motion. Yeah, it's pretty nice stuff. So that's the matching connector that's going to match with the connector on the control unit. So the connector on the control unit, the way I ordered it, has a 4-wire. It's a 6-position connector, but it's been custom wired from VaporWorks with only the wires that I absolutely need. The gray is a 5-volt reference from the map sensor. And then the blue wire is the trigger, the 12-volt trigger to turn the unit on. And then the orange and black wire is the ground wire for the map sensor. And then the light green is the output from the sensor. So it's a 5-volt gray wire to feed the map sensor, blue 12-volt trigger, orange is the ground for the map sensor, and green is the signal out from the sensor. This connector is obviously going to match this connector, which has about 30 feet worth of loom. So he gives you plenty of wire. Got the 40 amp fuse holder, 10 gauge wire, and everything you need to install this. So we're going to go ahead and get the process started. I'm going to unravel this wire loom, and what I'm going to do is obviously I'm going to get the loom pulled through the inside of the car from the firewall area and run this back to the controller where I'm going to mount, and I'm going to mount this controller on the battery box. So it's just a matter of cutting everything to length, crimping the terminals on the sensor wire connector, and going from there. All right, guys, so I don't know if you can see this, but here's the wire ends for all 4 wires. When the kit says it gives you 30 feet, they're not kidding. The end of the connector is kind of wrapped around the door handle at my Fusion. And here I am inside the garage, almost at the front of Ruby. And yeah, there's definitely 30 feet of wire here. What I'm going to have to do is I'm going to have to fish this wire from the inside of the firewall out. My blue wire I'm going to leave separate because I'm going to use this blue wire to tap into the, for us Fox Body guys, this is what we're going to use to tap into the fuel pump power, what originally comes out of the fuel pump power harness in the back, what would originally power your fuel pump. This is going to be the trigger for the unit. So I'm going to leave this by itself, spool it up, because that's going to get spliced in and soldered at the back. But just to go to, just goes to show you, you definitely get 30 feet of wire, so you shouldn't have any problem. Okay, and as we can see here from the instructions, there's your color coding per pin. Looks like pin 3 is at the top. That's your signal from your map sensor going to the unit. Number 2 is in the middle. That's your ground. And gray is at the bottom, which is pin number 1, which is going to be your 5-volt feed. So we're going to go ahead and match what's on here into this connector here with these bullets, obviously with the corresponding wire. Once I crimp these bullets in, I'm going to go ahead and probably just solder just a tip of solder on there just to make sure that I got a good connection. And they have some insulating jackets too, which are right here. So don't forget to slide these on. The flat side will face outward, and that just seals the connector for, being weather tight. All right, let's get to crimping and soldering. And here's my female bullet spade, all soldered and crimped. So I'm going to slide these into the connector into position, and obviously make sure that the spade is facing the right way. They're flat, and they'll click when they slide into position, and then you'll just slide the grommet back up to the back of the connector to seal it tight. And I'll do this for all 3 wires. All right, guys, well, here it is all installed, mounted on the battery box. The main connector for the map sensor harness along with the trigger wire. Just to note, the blue wire on this kit is actually the 12-volt trigger, and that's coming through the harness. What I've done here is used the factory Ford fuel relay, the main power out to what used to be the factory fuel pump. That wire, at least on the 88s anyway, I mean, I have all the EVTMs for all the years. I'd have to look to see if they're the same, but on this particular car, the fuel pump wire is a pink with a black tracer. That would power the fuel pump from the factory fuel pump relay. What I've done is use that wire to trigger command on to the controller. So the controller will operate as if it's in a stock, it'll prime for 3 seconds and turn off. But once it's running, just like we all know, when the EEC4 senses rotation, through the TFI system, it'll activate the fuel pump relay, which will turn on the controller, which will turn on the fuel pump. Here are all the posts and terminals. Hopefully it clears up. Hopefully you can see that. But anyway, it's all wired in. All my fusing is within the battery box, just like the kit has. I have 10 gauge wire feeding everything, 10 gauge grounds. So let's see if this thing fires up. Well, all right, guys, here we are in the car. We're going to see if this turns on. Of course, car's off. I'm going to hit the key, see if it primes. Yep, so it definitely primes. And let's see if it starts. Like stock, guys. High idle the way I want it. So obviously the fuel pump is doing its thing. I'm measuring the voltage on the pump from the speed controller. What you're actually seeing is a percentage of the voltage on the duty cycle. So it's still sending 12 volts to the pump. So this is the proper setting, about 8 3/4. and that tells me we have the right duty cycle at idle. So what's going to happen is under load, when the vacuum turns into boost, this controller is going to speed the fuel pump up, and you should see about 12 volts or system voltage, which is usually around 14 volts running wide open throttle. But just to give you an idea, this is how it works. So everything is working perfectly. Here we are back at the engine bay. There's the map sensor right there with a vacuum line going to the intake. Just a little overview of what I have under the hood. So what I have here, guys, are two fuel pumps that I'm going to show you that I'm going to use on future projects. Well, one current project and one in the late future. Here's my Aeromotive 18638. It's for a Fox body, 86 to 98.5. It's the 340 pump and hanger. This is the one that I have in the gray car. Love it. Don't have any problems with it. Like I said, this is the one that's going in another project that's coming up pretty soon. And these are the fittings that I use for the top hat. They're for Golas. But you can use this in a different variety of config. Or as far as the pump itself, you can buy the pump itself and modify it to the stock hanger, or you can just get this. It's already got it on the hanger. It's got the block, the terminals, and everything you need. Of course, the fittings I had to purchase separately, but these are the ones that I like to use. With this setup right here, I don't have any cavitation problems, like I said, on my 60 over 408 car, just because the volume of fuel that it moves relative to the amount of fuel that is consumed by the engine doesn't cycle heat through the fuel, causing it to cavitate. So this is a very streetable pump. Now, if you had a very stock motor, like a 302, bone stock with 19-pound injectors or 24s, I would not use this pump. You may run into cavitation. But if you're going to start using something like into the 36 pound per hour injectors, 42s, and so on and so forth, up to your max power level that this will handle, I would recommend this for the street. Like I said, it's not guaranteed that you're not going to have cavitation. But from my experience, the likelihood is going to be very, very minimal. So moving on to my other pump, that's another spare for another project. Now this is the one that I have in Ruby as well, but again, this is another one. It's the 12-347. And let me see if I can open this one up. Let's see here. Bear with me, guys. Now this is the pump in question that we're working with on the red car that I'm having, having to upgrade. Very similar setup. You've got the billet aluminum top hat block with 6 AN ports. But the pump is actually the TI Automotive. Let me turn this around. TI Automotive, and if you can tell, let me move the wires. The last 3 digits are a 285. So this is the 285 part number pump, which is a 525 liter per hour pump with the check valve on the outlet. Again, it's got the harness, billet block, it's got the hanger, and then it comes with the screen, which is in the box. Let me move these fittings. That's the matching screen. And the same fittings that I use on the Aeromotive pump hanger, these are the ones I use also for the Holly with the 285 TI Automotive pump. Feed and return, respectively. And these are going to be the part numbers. So again, guys, if you're having to run this pump right here, if you're having to run this bad boy, you are going to need a fuel pump controller. I mean, there's just no doubt about it. You're just going to have one. This thing moves. I feel this pump setup, this pump moves more fuel than the Aeromotive 1000 that I had on the red car. And why do I say that? Because when I had the Aeromotive 1000 on, I had the fuel pressure set perfectly to 43.5 psi at the regulator, which, I mean, that's system pressure on the feed anyway, anywhere in the system. I had the pressure set. When I took out the A1000 and put this pump in, my pressure went up about 5 psi at the regulator. So that tells me that this moved more volume for the same orifice restriction bypass at the regulator. So I had to drop psi at the regulator to get pressure back in line because of the extra volume that this pump setup was moving, which is why this video is being made, to show you the VaporWorks controller and why it's needed for this type of pump in particular. And from what I understand, this pump is used in several, obviously the Hellcat, it's used in some other applications, very similar applications, where they come with fuel pump controllers stock built into the onboard computer, to the engine computer, because that's the only way to run these things and not cavitate on a street car. So there you have it, guys. Now, on my gray hatchback, I have an Aeromotive Stealth 340 pump on that car, and it's got a 60/408, which is, 414 cubic inch AFR 225s, comp cams, XFI 236 cam, 42-pound injectors, TFSR, ported upper and lower intake, Cook's long tubes, that type of thing. All motors 60/408. And again, 340 Stealth Aeromotive pump, love that pump. I don't have any issues there, no cavitation. I feel the difference on the gray car, on the hatchback, is the difference in volume moved by that pump versus the amount of fuel that's consumed by the engine. The reason I don't have fuel temperature rising is because the pump moves less fuel and the motor consumes enough to where the cycling of the fuel back to the tank doesn't make the temperature rise in the whole system overall. So you might be questioning, well, when exactly do I need a fuel pump controller? And the answer is really kind of hard to answer all across the board as far as a standard answer, because you're never really going to know until you experience cavitation. But typically, this is going from my personal experience between the red car and the gray car, is the larger the pump, the more volume of fuel is moved. But in proportion, if your engine doesn't consume a lot of fuel at idle, you're going to be returning a lot of fuel to the tank. In a setup like that is when you're most likely going to need a fuel pump controller, which is the scenario I'm in. So as you can see, guys, very happy with the product. I feel personally, from my experience with these types of setups, if you guys are running enough horsepower where you need a 400, a 450 liter per hour on up pump, and you want to drive it on the street reliably, to me, this VaporWorks pump controller setup is a game changer. I mean, it really is, because I drive my cars on the street and I drive them for long periods of time. I've had nothing but good luck since I've installed this controller. The parts are top notch. The sensors are name brand OEM, made in USA, as far as the one that came with mine. Just everything's made in USA. The amount of wire that you're given in this kit, and again, guys, I'm not sponsored by VaporWorks at all. I don't take any money from them. But the way I was, with them calling me and spending their time with me on the phone for that length of time and really wanting to dive deep into what I had and my questions, the customer service is just really can't be beat. So when I have experiences like that, I really want to share it with other people, just because obviously there's probably other people that have similar setups that have similar issues and want them improved. But you know, it really goes a long way when you find a good product that you know, that lasts, made well, and solves all your problems, and you have good customer service. That to me is just, I mean, it really puts the cherry on top. So long story short, guys, if you guys have a setup that needs that type of a pump, definitely, and you need a controller, let's just say if you need a fuel pump controller, my recommendation is the VaporWorks. Now they have several different lines. Depending if you're running all motor, they have a kit for an all motor setup. If you're, you know, if you want to use the stock map sensor, they have a setup for that. My kit, as you saw, uses their standalone map sensor. So, but it uses OEM quality sensors. So you guys know me on that by now. So again, guys, thanks for sticking with me. I feel this is a game changer. Super happy with it, and we'll see you on the next one.